Yeah, good afternoon, good evening.
Uh,
Okay, so in this session, as we discussed already, the definition of linear, dependent, and then independent, we are going to solve two problems under this. With it, I'll close the session. So please, you can listen that. So it's quite easy. Okay, sometimes you will be provided set of vectors. Okay, the question will be asked to you like check whether those vectors will be uh, linearly independent or linearly dependent. Okay, how the way it can be verified. So that's a problem we are going to discuss in this session. So in the previous session already we have discussed the topic like linear combination and its related problems. Okay, so in this session we are going to just check the vectors whether it is a linearly dependent or linearly independent. Okay, so let us recall the definition already discussed. That is actually see here, listen carefully, very easy one. So here, if you understand the definition itself, means it is quite easy to get into the problems. They are provided set of vectors, okay, uh, of the vector space V. If they are linearly independent, means it has to satisfy one condition. What is that condition? See here, that condition is, that is, okay, yeah, yeah. If it is linearly independent, means it has to be like the coefficients must be zeros. Coefficients must be zeros. Like in this, all the coefficients must be equal to 0. Already the same question have arisen in the previous session. Anyway, we are going to just solve the problems under this definition. So that time you will clearly understand the concept. Okay. So here, first you need to enlarge the given vectors into the perfect linear combination. What does it mean of perfect linear combination? With a coefficient of vectors, you have to sum up all the vectors. Okay, then you need to make that right hand side as 0. Listen carefully, that is very important step. So you have to convert that right hand side part as 0. Okay. After that, if you are getting the answer, all the coefficients of the vectors, if it is equal to 0, then definitely that given vectors are called linearly independent. In this, any one of the vector, any one of the coefficient will not be equal to 0, or any two or something like. If you are not getting this format, means if you are getting any other format, then that time you can simply call that as linearly dependent. Linearly dependent. So only these two definitions. So with it we can enter into the problem. So that is quite easy. 1 minute. Okay, so we can solve the first problem. They are provided only pair of vectors. Pair of vectors. So you're going to just test whether they are linearly independent or linearly dependent. So what is our first step? We need to write in the linear combination format. So linear combination means, so a into x plus by equal to, what is the step they are given? Any guess? What is the right hand side part? Any guess?
0.
Very good. That is the condition to verify. Okay. So after this, further we can write in a well formal way like 1 comma 2 comma 3. I hope you can predict the remaining steps. 3 2 1 equal to. Can you just guess the right hand side values? Can you guess the right hand side value? Sorry. Can you please repeat?
Plus 3b.
plus 3b. No.
All
0,
zeros. 0,
0, 0.
Very good. You have to write the zeros in triplet. Okay. So because we are using here R3 space. So after that, that is the remaining steps will be easy. So here A plus 3b. This is the same kind of problem you are already discussed in linear combination. So that I am just continuing the topic, okay, linear combination, and then we are enter into the linear dependent. Okay, if you are understood about the linear combination problems, it could be easy to enter into the linearly dependent and then independent problems. Okay, fine. Next, 2a plus 2b. Last one is 3a plus b equal to 0 comma 0 comma 0 comma 0. So further I can write that like a plus 2b equal to 0, 2a plus 2b equal to 0, 3a plus b equal to 0.
A plus 3b.
Oh yeah, thank you. Okay, a plus 3b equal to 0. So here I need to check the condition whether all the coefficients must be equal to 0 or not must be equal to 0. So anyway, we have to check this condition. How the way it can be checked? So here you can easily follow the pattern, like you can write in a matrix format like coefficient of a, that is 1, next one is 3, last one is you are going to just write in the augmented format. Okay, 2 2 0 3 1 0. Okay, so can you please predict can you please state the method what we are going to follow here to attain the answer, like A B answer? Any guess? Already we are
It's Gauss elimination.
Cross elimination. Very good. So already we are solved some problems under this model. So we are going to apply the same technique over here. Reduced row echelon format, in which row 1 is already in well perfect form. So I can get into the row 2. In row 2, R2 minus 2R1. R3 gives R3 minus 3R1. So 0, 2 minus 6, that is minus 4, 0 minus, yeah, 0. Next, 3 minus 3, 0, 1 minus 9 minus 8, 0. Okay. Please stop me if I'm writing any wrong cells entry on this. Okay. Next one is only one part. So there is no change in R1. There is no change in R2. But in R3, then minus 2R2, right? 0, next 0, 0. Okay. So after this, further I can write that as like A plus 3b equal to 0. Next, 4b equal to 0. Can I write like this? After determination of reduced row echelon form, why not I can write in this format? Okay, so further from this I can say b equal to 0, minus 4b equal to 0, then b derives as 0. If you substitute b value there in the first equation, again a equal to 0. Now you can conclude the answer. What is the solution of this? Linearly dependent or linearly independent?
Independent.
Linearly independent. That's it. Problem is ended. Actually, this is a part of 10 mark. You last time it has been placed in the 10 mark question as a partial part, like a subdivision question. Okay, so linearly you have to write those two vectors x and then y are linearly independent. That's it. That's it. The concept is ended. Okay, very easy one. So the same method you are going to apply in any sort of problems. Okay. Before entering to the next problem, you can please start filling the attendance form quickly, and then we can enter into that. Please fill the attendance form quickly. Okay, we can enter into the next problem. So we can label it like our convenient, like x, y, and then z. So here ax plus by plus cz equal to 0. So this is the process we are going to check, like a into 1 comma 1 comma 1 plus b into 1 comma 2 comma 0 plus c into 0 comma minus 1 comma 1 equal to 0 comma 0. Always don't expect like your vectors can be present in the form like triplet. Okay, it can be a ordered pair or it can be a 4-element like pattern also. So here after this, next I can skip on step directly. I can write that a plus b plus 0c equal to, okay, next a plus 2b minus c, then a plus c, okay, equal to 0 comma 0 comma 0. Then further I can equate on both the sides the respective coordinate positions. So here I can get a plus b equal to 0, then a plus 2b minus c equal to 0, then a plus c equal to 0. Then to determine the answers of a, b, c, I have to follow here either Gauss elimination or Gauss Jordan. That's your wish. It is quite easy to proceed into the method Gauss elimination. Okay, because in Gauss Jordan you have to further expand from the reduced row echelon form. Can you please predict what is the further expansion from the Gauss elimination? Can you remember that topic? Can you recall it? In Gauss Jordan.
Sir, we have to get
Sir,
an identity matrix.
identity.
That we have to get the identity matrix in the left hand side. Okay, so remaining the values columns can be easily determined as the answers. Okay, so that I have just insisted here to follow the way Gauss elimination procedure. Okay, so here coefficients of a, coefficients of b, coefficients of c, and then constant part. So 1 1 0 0. Next 1 2 minus 1 0. Next 1 0 1 0. Okay, so let me apply the same reduced row echelon procedure here. There is no change in R1, so we can keep as it is. In R2, R2 gives R2 minus R1, so 0 1 minus 1 0. Okay, in R3, R3 minus R1. Okay, so 1 minus 1 0, 0 minus 1 minus 1, 1 0. Okay, after this There is no change modification in R1. So R2 also no change. But in R3 gives R3 plus R2 0 0 0 0. Okay, fine. So after this, A plus B equal to 0, then B minus C equal to 0. Okay. Any guess how the way it can be solved further? Anyone can predict the solution for this?
Substitution.
Just C equal to T, sir. Like,
C equal to T. Okay, very good. So, how you have predicted C as T?
it was a free variable.
Dummy variable.
Very good.
Yes.
Free variable or dummy variable, because here dummy variable is C. So I have to keep here C as T, that T belongs to R, then B equal to maybe plus T. So you have determined A, B, C. After that, A equal to, I think, minus T. Okay. So have you got here the answers, the coefficient of vectors as zeros?
No, sir.
Then what is the solution?
Linearly dependent.
Linearly dependent. Before that, you have to mention one sentence here. It has infinitely many solution. I hope you can remember the sentence which we have followed in model 1. Okay, so because of the reason we are having two equations with three unknowns. If the number of unknowns is more than the given provided linear equations, means that definitely you can conclude that system is consistent and it has infinitely many solutions. So here you can conclude here x, y, z are linearly independent or dependent?
Dependent.
Dependent.
Okay, that's it. Okay, so last only one problem with the red close. Just spend 5 minutes with the red close. Okay, so here I'm not going to solve this problem completely. I can just assign this problem to you for the practice sake. See here, the same procedure, but layout of the vectors is completely different. That's it. Okay, no other modifications can be done in the problems solving procedure. Okay, but the layout of the vectors is slightly differ when you compare with the previous one. So there it was given like 1 0 0 as a triplet they are given here, but here they are given as the column vectors. Okay, sometimes the questions can be given in that layout also, so you have to be ready in both the formats. So here simply you can keep as it is in the layout, like column vectors, like 2 sorry, first I need to label it like x, y, z. Okay, so here ax plus by equal to 0. Okay, now I'll be rising on question. Okay, be ready for that. Okay, see here, a into 2 2 1. Next, b into minus 4 6 5. Can you please predict the right hand side? Can I write here like this?
No, sir.
No. Then
0 0 0
Column
column
wise.
very good. So you have to write as the 0 column vector, like 0 0 0. Okay, if you do this step, rest of the procedures are completely same. See here, I'm not going to solve the remaining steps, so I can just leave up to this. Here 2a minus 4b plus c 0 0 0. Okay, next 2a plus 6b plus 0c equal to 0. a plus 5b plus 0c. Okay, further it can be separated as three linear equations. So by solving the method of Gauss elimination, you can conclude it whether it is a linearly independent or dependent. Okay, have you understood this method, linearly dependent and then dependent?
Yes, sir.
Okay, so I hope you can complete the remaining steps. So I'm just leaving for 1 minute work to you. Okay, so I hope you can able to complete the remaining procedure. Okay, so in the next session, what we are going to discuss, that is span. Span. Okay. What is the meaning of span? Just I can complete with this slide itself. Please listen. See here, they will be provided set of vectors from the vector space V. Okay. Among the given set of vectors, if you pick any vector from that set V, okay, if it is possibly written as in the form linear combination of the remainings of all the maybe that is belong to the vector space. If it is possibly written as the linear combination, means then you can call that set. That set is called spanning set. Okay. If you read this definition, you can easily understand it. Otherwise, not an issue. I'll solve the problems under this model, linear span. Okay, spanning set. See here, you have given the set, vector space set, from which any vector you can pick randomly. That vector, if it is possibly written in the format linear combination, okay, so then you can simply state the given set is actually spanning set. Okay, by the way, you can pick some sets. You can find some number of sets that will be discussed as the problems in the next session. Okay, this spanning concept will come under the major topic, that is basis. Okay, basis. So that will be discussed as a detailed manner in the next session. Is there any doubt up to this? Is there any doubt?
No, sir.
Okay. Actually,